So for this assignment, we're going to be working in chapter 4 to recreate some of the images that are made in the book. So to start, what we're going to do is look for the graph that we're going to make and just kind of scroll down. As you can see, this one is all about making lots of different layers for facets. So we're going to focus on recreating this one 4.4. But for this video, I'll show you how to work through all of these so you get a sense of what this chapter is all about, at least from a coding perspective. And hopefully you can use some of these codes in your own work. Okay, so to start off, I'm going to go ahead and create a new R Markdown. So I'm going to work in the same folder that we were at last time, where I have my workspace and chapter, and I'm going to say set as working directory, so it knows that all my files should be saved in this area. And then rather than working in my old Markdown, I'm going to create a new one. And for this one, I'm going to call this a chapter for homework. All right, and so I have an untitled document here. I'm going to save it right off the bat so that I know I'm keeping track of my work. So chapter for homework. Great. Now, like before, I want to make sure my packages are installed. So I want to go over here and look for the tidyverse, which is one of them. Want to make sure that's installed. And I'm going to put a command here that says require tidyverse. You can also do library tidyverse after you've installed it. I'm also going to require another one called soakviz, which is a package. You might have to install this one since it's not always showing up here. To install it, you go here, click the install packages button, and then do soak, S-O-C-V-I-Z, soakviz to install that. And then we're going to use one other one too for this, and that is the Gapminder data that we used last time. And again, if you don't have it in packages, you can find it, Gapminder, as one of the packages in this CRAN. So that should be downloaded as well. And I'll just go ahead and run this code, make sure I don't get any errors. So it looks good so far. Now, like we did last time, I'm going to start by just kind of gutting this and, starting with the title here, recreating figures from chapter 4. And then I can type some plain text. First, we will remake figure 4.1 period. Okay, so in my first chunk here, noted by the 3 backticks at the beginning, a curly bracket, and then R specifying the code, and then the name of the chunk. I'm going to rename this to be figure 4.1. And inside of this chunk, I'm going to start with my code for this particular graph. So let's go ahead and scroll down and see what it is that we're trying to make right now. Now this section is all about the grammar of graphics and how you can kind of build things through layers and the benefits of grouping. So the first thing is, let's see what happens when we group the data, or rather what happens when we don't group the data. So we have a plot here. This looks like it was made by mistake because line graphs typically connect the dots instead of just going up from 0 each time. So let's try and recreate this plot. So it looks like I'm going to create an object called P, and stored in P is the ggplot function with 2 main arguments. Data is the first, data equals Gapminder. And then I'm going to have a second argument, mapping, which in this case is the aesthetics, AES. And for the aesthetics function, I have 2 arguments. First, I have to define what X is. X will be the year. So that'll be my x-axis. And then the y-axis, the vertical will be GDP per cap. All right, and then that alone should, I'm going to press Command Enter or Control Enter, depending what computer you have. So you can see it made an object called P, but P on its own isn't going to make a graph. So I have to call P, lowercase p, plus geom underscore line in order to make the graph with the ink. Okay, so that looks pretty close to what they had. And so this would be trying to plot the data over time by country. Yeah, so that didn't work out too well. We can't see the countries. It's not clear how these lines are connected. So let's keep going. So what if we instead focus on grouping things by country? So as you can see, now we're going to do the same thing. I'm going to copy this text down. And actually, I'm going to get rid of this old stuff here. And I'm going to create another line of plain text that says, next, we will try to create a grouping for figure 4.2, period. Okay, and then I'm going to paste that chunk from above down here. But this time I got to modify it. First, I'm going to change the name of the chunk so it's not duplicated. 4.2, and then inside of these brackets, looks like we're going to have the same arguments for the ggplot, but what's different now is I have a new command under geom for aesthetics. We're going to specify that in the aesthetics group, this is how we're going to group things. We're going to group things by country. Okay, and it looks like that worked. So I'm going to run this line. Oh, and wonderful. So now you can see there's lines connecting all the data points. And as we look across the years, we can see that they're connected. But this is also not very useful. This just looks like a bunch of lines. It's really hard to interpret any trend here because it's just too cluttered. So I think we can make some more improvements. So how about a facet? So facets are great because what they can do is break up a graph into multiple panes. And then from those panes, you can kind of show different categories across the panes. So for this, we're going to add some more plain text here and say, next, we will try to add facets to make the trends more clear across the groups of countries. Across groups of countries. Okay. So now we added our figure, copy and pasted. We're going to change that to 4.3. And for this part, it looks like, notice how the facet has broken up the pane into 5 different continents. So each country belongs to a continent. And if we use continent as a variable, we can split this up. So let's add another line to this. This time we're going to do a plus sign, and we're going to do facet wrap as another function that we add to our ggplot p. And we're going to add facet wrap, and then we're going to do this tilde key that's going to say take all the variables and compare them by continent. And so when we run this, we should get 5 different continents, each one showing their trends over time. And we see the GDP per capita on the x-axis. Notice that it's not repeating the axes every time. It's just doing it where to the leftmost position, so you can look across and make comparisons across all of these. And similarly, the y is repeated, so we can go up and down, and that's maintained. Okay, so this looks really good. Now we're going to work with polishing this up a little bit, make this a little nicer. So remember that ggplot works through layers. So our first layer was identifying the data. Then what we do is map the aesthetics. So we figure out the X and Y plots, and that gives us our kind of canvas to work on. And then once we have our canvas, we want to put ink on the page using geom. And as you can see, now we can duplicate that canvas by multiples with the facet wrap command. So we're going to do the same thing, and but this time with the more polished version, and we're going to add some trend lines here. So we will keep improving this image by adding better scales, labels, and a trend line. Okay, so now we have to update this. Figure 4. Gapminder is here. And let's go ahead and add our layers. So looks like it's using color gray 70 here. So we can do the same here. Color equals gray 70. And since this is a named color, I'm going to put it in quotes, so it treats it like a string of text. And we got their group in there for country. So I'm going to create a new line after this plus, and then add the geom smooth. This will add a nice kind of line that helps to specify what the overall trend is. So this one says it has a size equal to 1.1, and it's going to use the method of louses. And then we're going to add our standard error so we get a sense of how much, or sorry, we're going to specify not to include the standard error by SE equals false as an argument. So we have a geom smooth with 3 arguments, 1 on size, 1 on what method to use. Remember, we could make this a straight line if we wanted to using LM. And then we specified that we won't add the standard error. Okay, and then the next thing, it looks like we're going to add another line of code. This is for the scale. So notice that it's really hard to compare these numbers because this line right here is so big, but these other ones are so small. They kind of group together. So if we add a logarithmic scale, I think it'll help kind of spread out the data a little more and give us a sense of way of kind of unpacking the smaller ones. And we're also going to add an argument within the scales to equal that, so that it shows up as dollars. Yep. All right, great. And then now we have facet wrap as our next one. This also has a new argument called ncol, which is short for number of columns. So rather than having it kind of like this, it looks like there could be 6 panels here if we had another continent. Instead of that, let's just put them all in one row like this figure has. So to do that, we have to specify how many columns are in the facet wrap. And let's do one more. Now we're going to add the labels. And we can do that with x equals quote year, comma, y axes. Now we specify what we want written there, GDP per capita. And I always like to add these labels just because oftentimes the variables aren't very clear when they're written out. So we'll do another comma here and another argument, title equals GDP per capita on 5 continents. Okay. So it looks like we got a complete code so far, no error messages. So let's run this and see if we can make the same figure that we had before. Oh, and we got a error already. Oh, I forgot to add a second colon after scales. So when you have a double colon, it means find this package called scales, and then within scales, use a function called $, or object called $. So the double colon just says, makes it specific to which package you're pulling this information from. Oh, look at that. So our color, I made a rookie mistake here. I should have put the color outside of aesthetics, and instead I put it inside. So let me go ahead and move that out of there. But as you can see, we got our facet graphs there. So I'm going to do geom line, and then the first argument is color, and then the second one will be aesthetics function. Okay, that looks a lot better. And so as you can see, it's got this nice kind of spread out look. We can see kind of more individual trends because we're on a logarithmic scale. And we got that nice blue line to show us kind of overall that every continent is increasing in their GDP. And so you can make this a little bigger. This helps because the axes down at the bottom are kind of scrunched together. Notice how hard that is to see there. But when you make it bigger, now you can kind of see it's played out a bit better. Now, it doesn't look exactly like the one they have here, probably because there's an extra theme. So I can do a theme underscore minimal. So I think that the designers of this graph probably had some more information to make it, publishable for the book. So now that got rid of the gray background and makes it a little kind of cleaner compared to what we had earlier. But you don't have to include that. That's mostly just for those curious why theirs looks a little different. Okay, so up to this point, you've gotten all the figures. You showed how to use grouping functions to pull data apart another layer. And then you also use the facet wrap in order to create separate panels of the same data set by a particular variable. So that's what I want you to accomplish from this reading. And at this point, you can go ahead and knit, and hopefully you don't get any errors. And as it knits, you should see down here the little viewer pop up. And if we open that up, we can kind of get a sense of what we worked on. And notice that our text is here, our code is here, and our graph is here. So this is enough that you can submit this for the assignment. So to do that, you go to File, and then you find your folder, and you should see that HTML document that was knit. And I have duplicates right now, but it should just be one once you refresh. So this is the file you'll submit. But for curiosity's sake, I'm going to keep working on the other plots here so you get a sense of what else we can do. So the next data set comes from this GSS, which is a measure of what's called the General Social Survey. And this shows a lot of things about kind of American makeup, demographics, everything from the religion to race, ethnicity, gender. So let's go ahead and keep working here. So I'm going to create a few new lines. And now we will work with the GSS data set using GSS SM. Okay, so I'm going to add another chunk here. So a quick way to add chunks is go to Insert here and see this kind of plus C. We can do Insert Chunk that way if you don't want to type it out. Okay, so we're going to create an object that stores the output of ggplot as P. So ggplot, and then first argument, we're going to specify our data, GSS_SM. I might have to load another package here, but we'll see if it pulled it down right away. AES. So our second argument, again, is mapping the aesthetics layer. So if we want age and we want children, we can put those all together. And then we're going to close the bracket. So that's our P layer. And then from P, we're going to add a geom point. And then the alpha is going to give us some transparency within our points. So this is going to be a scatter plot based upon the argument that we're using. Then we're going to add a trend line, geom smooth. And we don't put any arguments there. And then we're going to do a facet grid, so separate out the these variables by sex and race. Okay. And let's go ahead and run that. Okay, great. So now we see a general trend. So it shows how old people are, how many children they have, and then, varying it by race and sex here. Looks like it's only white, black, or other though. Okay, so this is useful because it helps to show that you can do this kind of facet grid even with a bunch of scatter plots. And then you can also add to this formula if you want to pull out extra information. Okay, so let's look at some other graphs that we can make. So this one looks like you can separate people out by which region they reported from. So, oh, I forgot to add the name of the figure here. This was figure 4.5. Okay, so let's go ahead and do this same kind of work here. We're going to go create a new line down here for the plain text. Now we'll work with the GSS data set to show the respondents by region. Okay. So again, we're going to insert a R chunk. Let's name this figure 4.6. And we're going to practice making a bar chart here. Okay, so it looks like we have an object called P that we're going to store from our ggplot. Data equals GSS SM. Mapping equals AES. X equals big region. And then we're going to make a bar plot of this genome bar. So that's going to be where our ink comes from. So that looks great. We have the count by each of the regions. And as you can see, it makes a nice kind of graph there. Okay, so let's go ahead and try figure 4.7. So what this is going to do is take the proportions. I'm going to copy down the whole thing. Next, we will make a proportion based bar graph. So we'll make a proportion based bar graph, and it looks like the same thing, except instead of the aesthetic being the count, we can say this aesthetic should be the proportion of that group. So in here, I'll do mapping equals AES, Y equals ... prop ... So this is kind of a shortcut for it to find the proportion within the X. So it'll take a calculation for us. And as you can see, like, of the Northeast people, all of them are accounted for. So they get a 1. It's the same as like 100% would be a proportion of 1. So this is really useful because we can switch this argument out depending on what kind of information we need. So now we can also add a layer so we can see the relative proportion across the groups instead of within each one. So I'm going to copy the text down and get my chunk. So next, we'll make a proportion-based bar graph for the country level. Here, I should say across regions. That's probably better. So we'll make a proportion-based bar graph across regions. So now I'm going to add the same thing, except now I specify my group as comma 1. I'm going to change the figure number there. Group equals 1. And so that's just going to take that first grouping of the big region and then use that to determine how to divvy up the proportions. Good. So now we can see that the general shape of the bar is the same as it was before, but instead of counts, now I can see the proportion of each region. And what's nice about this is I can also add another table here. And this can give me things like the religion. So table GSS_SM. So that's our data table that we're working with. And then if I do money sign region, it's going to pull out the column called, pull out the column religion by money sign religion. I can make a count of how many different religions are counted there. So that works there. And notice it gives me some output. I can see different faiths that people have identified with. So let's see if we can map out the religious preferences from this survey. So I'll go ahead and copy this down. And we're going to say figure. Okay, so this will be figure 4.9. So we're going to remove some of these. So instead of by region, we're going to do religion. And the color will help us also separate out religion. So our arguments are aesthetics, X equals religion. It would help if I spelled that right. And then color equals religion. And looks like we can remove this. Okay, so I'm going to create this first one just to see what this looks like. And so notice we use color here, but when you use color, it only gives you the outline of the color. It doesn't give you the inside. So we need a different argument for this. And that's where the second one comes in. We're going to use fill to specify. So instead of P being the ggplot with the color, we're going to say, make this fill. No parentheses there. It's only an argument. And then we'll do geom bar. And it looks like we want to add an extra piece here since we don't really need a key. We already have the religion specified at the bottom on the x-axis. So we'll just say fill for the guide equals false. So that will remove the key overall. So let's go ahead and run this. It didn't like something. That's because I used the function guide and it should be guides. Okay, so there we go. So that's our second plot. First one, again, this has the guides and it has color as a specification. This one, fill and no guides. So there's no key there. So this is great. And now let's try and do some other things. So oftentimes you might see a stacked bar plot or column plot like this. So here we are adding fill to map the religion counts. Okay, so for the next one, we're going to do some more. So for this one, we will create a stacked bar plot of religion for each large region. Okay, so this is going to be pretty much the same thing that we did before. So what I want to do is I'm going to specify that this time X is going to be the region, big region. And I can keep my color as religion. And that will help to show what portions within each of the bars the religion is identified. And so I can do P plus geom bar. And this should give me a simple count of each of these things. Oh, and I need to update figure 10 and big, did I spell that wrong? Oh, there's no underscore, big region, BIGREGION. Okay, and that looks like it worked. Oh, and instead of color, we should have written fill. So it's kind of like how we had it earlier. There we go. All right, so that's looking good. We'll do the same thing. We'll add some proportions to this. Okay, and so the easy way to do that, of course, is just we add this other thing called position equals fill. And so what that will do is spread out the size of each of the bars so that they're all the same. And now we can compare the relative proportion across the different regions for each religion. And so that was figure 4.11. And sometimes you get these weird, wacky things like with the Dodge chart and a proportional bars. That can be a mistake. So it's because the fill is already accounting for proportion. So if you do fill with add fill and proportions, if you do both of those, then you're going to get this kind of weird weird thing. So oh, and actually this is called Dodge. So if we position the bars so that they're side by side instead of all filling on top of each other, we say we do position equals Dodge. Here we have the mapping equals AES. Y equals dot dot prop dot dot. Okay, so oh, it looks like I misspelled. Spelling counts. Okay, so yeah, now I have this kind of rainbow set up for each region with proportions, but that's probably not the most useful. So that was figure 4.2 because everything looks the same, so we can't really differentiate the information there. But now it looks like we can kind of layer on more information, but using the groupings to help show the proportion within each of them. So the stack bar plot is useful, but if you're trying to make comparisons that are not matched up, it can be really hard. So having everything on the same axes and the same height for comparison can be really useful. But it also makes the chart a lot busier. So we're going to add groupings to our Dodge plot with proportions of religion for each large region. Okay, so this should help us kind of make comparisons across the regions, but also show the relative percentage within region. All right, so for the big plot, we have, looks like basically it's the same thing. We're just adding another aesthetic called group. Group equals religion. So by having that, we know that it'll take the proportions within religion, within region. And there we go. So we recreated that. So what this says is, about 0.1% of the population in the Northeast is considered Protestant, and as high as it looks like over 0.5% are identified as Jewish. And now if we look at some of these other ones, though, like the Midwest, we can see that the proportion of people identifying as Jewish goes down quite a bit. So we can make comparisons across the regions and kind of get a sense of, we compare across colors, how the different areas fare. Okay, so the next thing is we're going to keep working. Now it's going to make a little facet grid. This is nice because now we don't have to use color so much for the comparison, and we can get a better sense of how things differ. All right, so to do that, oh, and actually this is a proportion of the religion across the region. So even there, it's not that, you know, 50% are Northeast, it's that of the people who identify as Jewish, 50% are in the Northeast region. That makes a little more sense. Okay, so let's go ahead and copy this down. We're going to do another one. So now adding facets within the regions for proportional comparisons of religion. So this will be figure 4.14. And basically we're going to do the same thing, except we're going to get rid of the color. So no more fill. And we're going to add the facet wrap. I got to add a plus sign at the end here. And then we do facet wrap. And since we want each panel to be a region, we'll do big region. And the number of calls can equal 1. So this will make one long graph. Oh, that's not quite right. Oh, that's because I did group by religion. It should be by big region. Oh, and this one got changed too. So the X is now religion. That's what's going on. Okay, so I need to pay more close attention to where I'm putting my variables. So for this one, the X represents different religions. And so think about this as making one single plot, right? And so this one would have X as the religions, the proportion of each religion would be the Y, and then those would be organized and calculated by group of the region. And then the facet grid will display each of the different regions. Okay, so this should work now. Yeah, so this works. Theirs is a little different because they use 2 columns instead of 1. But I can pretty easily alleviate that with specifying this as 2. There we go. So we recreated that graph. Next up is histograms. So these are going to help show distribution, and they usually require some kind of bin. Looks like I was misspelling things. So let's go ahead and go down to a new section. So I'm going to add a little header here, say histograms. This will be figure. Which figure is this? Figure 15. It looks like we have a new data set here. So instead of the data being from GSS smalls, we're going to do Midwest. Instead of mapping for religion, it looks like we look at the area. And this time we're going to do, instead of geom bar, we're going to do geom histogram. Okay, so that should give us a sense of the area. Okay, so this is great. So we see kind of a distribution that's close to normal, but there's a pretty long tail over here. So I'd say there's some skew. But it looks like we can also focus on binning these so that we can get a better sense of kind of the smoothness of the curve. So we'll recreate this graph, and then this time we'll add an argument inside the histograms for bins. So what that does is it's going to create kind of a intervals by which we combine the data and count it. And so now you can see that every 10, there's a bin for it, and the area gets grouped together a bit better because there's 10 places that you could put the point. So next up, we're going to add some color to this. So it looks like there's Ohio and Wisconsin. We can compare the different county sizes. And it looks like we can also use that aesthetic to make some transparencies within our data. So I'll make some new lines. Next, we will show the distribution of counties by area across Ohio and Wisconsin. Okay. Oh, I misspelled Wisconsin. Forgive me for anybody who's from there. Okay, so now we're going to do figure 416. So same data set, but we need to subset the data. So this little function is pretty nifty because you can pull out particular parts of the data set. So we want to subset the Midwest and gather the subset in which the state is equal to OWI. So this will be only the states that have Ohio or Wisconsin, and X equals per college and fill equals state. All right, and then we're going to add our alpha here. I need to specify what I mean by OH. So we need an extra argument here. So what this is doing is saying find the states inside this list of Ohio and Wisconsin, but we didn't specify where that list is. So Ohio, Wisconsin will be an object that we store, and it's going to contain the terms OH and the term WI. So we use the C to combine them into a single array of values. And as we do that now it can know, okay, the two states I'm going to subset the Midwest to are Ohio and Wisconsin. And it looks like I can count the per college. So I'm guessing this is about voting stuff. And now we get this nice histogram with both states showing up. And you can see they're kind of stacked on top of each other. So you can think of this as the combination of the two. Okay, but let's try to do this with some lines and show the distribution with the density curve, which is kind of a similar way of showing the histogram. So now adding a density plot. So for this one, we'll do AES equals area, and the geome equals density. And it looks like we remove the subset. Here, there's an extra parentheses there. It just needs a comma. Okay. So there we go. Now we have a nice density graph, shows kind of the peaks of where all the points are falling. It should match what we had before. All right, and then it looks like we're going to use this to kind of separate things out by states in the Midwest. So what color do you think we'll use? We're going to specify states as color. Here, and actually, we don't need this stuff anymore. So I'm going to get rid of the OH, WI. Now we add a density plot with each state shown. Okay, so now we add a density plot with each state shown. So for that, we can do 418. And this should be pretty easy. I think we just have to add a fill equals state. Oh, we're going to do both state for fill and for color so that we get kind of a nice outline as well. And then we can do alpha equals 0.3. There we go. So that's great. We can now compare the distributions, and then let's do the same thing with the Ohio versus Wisconsin. And it looks like we're going to scale it a bit more. So we'll do a subset again, subset of the Midwest by taking the subset in which the state is in our object called Ohio, Wisconsin. Since we already added this to our environment up above, it should show up here again without any problems. And then again, we're going to do mapping. This all stays the same. And instead of just having the alpha here, it looks like we add another aesthetic AES. So mapping equals aesthetic AES, Y equals ... scaled. And so this will help correct for the lack of size and counties. So we get a sense of the distribution overall. Okay, and there we go. So we're able to show that. So let's go ahead and move on to that. Titanic. Okay, so for this one, we're gonna make so categorical data oftentimes gets shown with these kind of plots. So making a bar plot with side by side gender comparisons. Okay, so I'm going to do the insert chunk here. I'm going to call this figure 420. All right. So yeah, so the Titanic data set has some information there. We can see how many people perished, whether they were male or female, what was the number, and then the percent within each of these. So if we wanted to visualize this, we'd have to start by kind of adding the layers one at a time. So we'll do the same thing. Store an object as P. And that object will be the output of ggplot function. And this will be data equals Titanic. Titanic mapping equals AES. X equals fate. And then we want to graph the percent. And then the fill equals X. Great. All right. And then the next thing is we're going to do geom bar. So this is going to make our bar plot, and we don't want them stacked on top of each other. So we got to specify the position is dodge. So they go side by side. And identity or stat equals identity. So we're not going to ask it to make proportions for us since we already calculated out the percentage, or it was calculated out for us. So we'll just, identity means that you do verbatim what is given. And it looks like we can add a little theme here too. I'm going to do this on a new line. Theme. Legend dot position equals top. So that's just going to put our legend up at the top, which you can see here. So there we go. We got the percent of perished or survived within each group, or I guess relative to the total number of people. All right, so we can also do the OECD sums here and create a similar kind of life expectancy plot for our using bar plots and columns. And so this is a great example because it shows how you can go high and low. So again, we're going to pull up this data, OECD. So those are some of the highest GDP countries show up in these, and it looks like we got their we got dates and time or years for all of them, and then the USA compared to the others. So let's go ahead and make a ggplot of this. So we got our data set, OECD _ sum. For mapping, X is going to be the year. Oh, this is figure 4.21 now. Y equals the difference. I'm assuming that's the difference between the US and the other countries. And then the fill will be high-low. So that'll help us distinguish when it's above or below. All right, and then I'm going to close that argument with an extra parentheses. So that's our ggplot. And then instead of bar, we're going to use col. So columns are just like bars, except they won't default to count data. Instead, they'll show you what you specify. And then it looks like we want to turn off our guides. Fill equals false, so that those don't show up as a key. And then we got some titles here. Excuse me, labs. X equals null. Y equals difference in years. And then we'll do title. Oh, this should be in quotes. That's why it's giving me an error. Title equals quote. Oh, and this should be null. Okay, so title equals the US life expectancy gap. Subtitle equals difference between US and OECD average life expectancy 1960 to 2015. Okay, and then we can add a little caption there too. Comma, caption equals quote data OECD period after a chart by Christopher. Okay, so it looks like we got that. We don't need the theme anymore. It's giving me a little error. Let's see where this is at. Okay, I think it's because I hadn't closed the brackets or the parentheses right. Okay, so I'm just gonna, this is bothering me that it's not aligned, so I'm gonna fix that. All right, and let's see if this works. Hey, look at that. So it looks like for a long time, the US had a longer life expectancy than most other OECD countries. But that quickly fell off around the 2000s. Interesting. Okay, so there's a graph. We got to make it the way it looks, and we could probably polish this up again if we add the theme, that theme minimal. And that'll just, clean things up a little bit. Yeah, so that looks pretty good. All right, so there's some more things to do here if you want to play around some more. But again, you can just stop at 4.4 and that'll be enough to knit the object. So I'm going to test this out. Let's see if I have any duplicate chunks. It would give me an error here if I do. Hopefully I went through and named things appropriately. Yep, okay, so can't find object. Okay, so that Ohio thing that we made, looks like it got deleted at some point. So we should probably add it back here. Okay, so let's knit that now. Hey, much better. All right. So we can see all the work we did for this chapter, recreating each of the figures. And we learned about histograms. We learned about how to, manipulate the columns and bar plots to show things that might seem different than how we normally use it. So great job, and keep with it. You can do it.